definitions. What is a secant line? No idea. From geometry, what's a secant line?
Oh, it cuts across
2 points, yeah, in line. That touches a curve. At 2 points. So line PQ here, that is a secant line. Okay, see how it touches our curve in 2 points. What is a tangent line? Okay. Line touches a curve. All right, so when we're finding a derivative, what we're actually doing is finding the slope of the tangent line. So to a curve at a specific point. Now, when you find slope, how do you normally do that? Rise over run, or you've got like 2 coordinates and you do y2 minus y1 over x2 minus x1, right? Like we've been finding slope for a very long time. Yeah. So if I have a tangent line and it only touches it in 1 point, do you see how that's going to be a little trickier to find slope? Okay, so we're going to figure out how to do that using the secant line. So let me show you in these little pictures down below. So if I start with a secant line, so at these 2 points, I want to bring those points closer and closer together until they're almost the exact same point. Because then what has my secant line become? Tangent line. Okay, that's what we're going to do. We're going to use the slope of the secant line to find the slope of the tangent line. So let's look at this picture down here. Okay, guys. You got it. You have to do it with the definition. Okay. So you got to pay attention. It's great if you know the derivative rules already. Not great for you on your quiz and test if you refuse to do the definition. Okay. All right. And understanding it helps with you using it. Okay. All right. So I've got these 2 points here, P and Q. I'm going to label P as X and F of X. Okay. And then this little bottom piece of my right triangle here, it says delta X, but I'm going to call it H, just so I have a distance to reference. So any thoughts as to how I might label Q if I know I'm moving over H?
X plus H.
Yep. And then F of X plus H. Okay, so those are my points, P and Q. Let's think about how I would find slope of the secant line here. So isn't slope always y2 minus y1 over x2 minus x1, right? Okay. What do you think it's going to be for my secant line here? I'm going to write it down below too. What is y2? F of x plus h minus f of x over minus close x, yes. So slope of that secant line is going to be f of x plus h minus f of x all over just h, right? Is that really anything new that you didn't notable below it? I mean, we're putting h's in, but isn't that just slope? Okay, so now that's of the secant line. Let's think about what we're doing if we want to turn that into slope of the tangent line. So I am taking point Q and bringing it closer and closer to P. What is happening to H as I do that?
It's close.
Smaller and smaller and smaller. And what do I want it to get really close to? 0. So the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h. It makes sense, right? It's just getting closer and closer together, so h is approaching 0. So that limit definition is what you're going to use to find derivatives today. So you can see how there's going to be some algebra to simplify everything on the right side of that. All right, questions on where that definition comes from, or is it making sense to you so far? So, thumbs up, sideways, down. I'm getting just blank stares right now, so we're okay so far? Kind of? Okay, yeah. The limit as h approaches 0 of f of x plus h minus f of x all over h.
This is for just this graph.
No, that's general with the x's and the h. That works for any graph, any equation you are given. That is the limit definition of a derivative, also known as slope of the tangent line.
Where does this fit in the circle? Circle. What do you mean? All around the circle. I don't know, it just seems a little bit out of place.
Well, we were just, you had to do limits before we can do derivatives.
Yeah, I understand that, but like,
You mean the tangent part?
why are we using secant lines and tangent lines?
Well, they don't actually have to be where it intersects a circle. Like in geometry, that's all you did with them. It touched a circle in 2 points, or it touched a circle in 1 point. It doesn't have to be a circle, it's any curve. So like here we have a parabola. Okay. It can be like a crazy funky shape that's just like, and I can say find the slope of the tangent line right there. Okay, so then we find that. Okay. All right. So it's not all, and it has nothing to do with tangent in terms of like true things. You know, it's not sine over cosine. Okay. All right, so let's try some. You turn the page for me. This is just saying everything again as far as the definition for the limit definition of a derivative. Sometimes you'll see it with a's instead of x's. Sometimes you'll see it with a delta x instead of an h. They mean the same thing. It's just notation and how you can write the derivative. Now this part in the middle, these are notations for finding the derivative. You know how if you found the inverse, you would do like f to the -1 of x, that meant inverse? Okay. We have notation for derivatives too. The first 3 you will see a lot in here. That's f prime of x, dy dx, and then y prime. Those all mean derivative. The others do too, d dx of f of x and dx of y, but we don't use that notation quite as much in pre-calc. Okay, let's try one. All right, so number 1 says find the slope of the tangent line to the curve, and I give you the curve, where x equals 1. At any point, do I say find the derivative? No, but do you know that's what I'm asking you to do? Yeah, so a lot of this is making sure you understand what the question is asking you to do. So we're going to write this out. So I'm going to write the limit as h approaches 0 of f of x plus h minus f of x all over h. Yes, you have to write the limit as h approaches 0 every time, okay? Okay, two ways to do this. We could leave it as f of x and just go through the general rule for all of it, and then plug in our x value at the end. Or we, since we're given an x value, we're looking for it specifically when x equals 1, we can go ahead and just start by plugging that in. I think that's slightly easier because you just have numbers to begin with. So what that means is instead of f of x plus h, I'm looking for f of 1 plus h minus f of 1 all over h. And guys, you are a little tight for room on this one, okay? So you write huge, write smaller. All right, so let's think about this. We've got limit as h approaches 0. What does it mean when I say f of 1 plus h?
1 plus x is
Okay, in general, what does it mean? Like, what if I said f of 5? What would you do? Plug 5 in for x. So when it says f of 1 plus h, what does that mean?
1 plus h.
Yes. So I'm going to have, this is my f of x, right? So I'm going to have 3 minus 2 times 1 plus h minus 2 times 1 plus h quantity squared. Minus f of 1. Well, what is f of 1? Negative 1, yeah. We get that just by plugging the 1 in. And then that is all over h. Okay, let's stop there for a minute and make sure everybody's seeing everything we're doing. I think I have questions in the back. Maybe. Maybe not. Elena, you good? Are you sure? Okay. All right, so then we just have to start simplifying. So, again, I write limit as h approaches 0. I have 3 minus 2 minus 2h. Now, do I distribute the negative 2 before I square? No. So let's just go up here off to the side and square that real quick. What is 1 plus h squared?
squared.
Yes. So I'm taking all of that times negative 2, okay? So I'm going to have negative 2h squared minus 4h minus 2, and then plus 1 at the end, and all over h. It's about to get much more simple, guys, okay? We're okay to that point. Okay. Limit as h approaches 0. All right, so I've got 3 minus 2 plus 1. What does that come out to be? 0. Then I'm going to go with my negative 2h squared. And looks like minus 6h. All over h. Getting better?
Yes.
Okay. Guys, now you are back to just evaluating a limit like you were doing in your homework yesterday or last time. So what should my approach be? Because I can't just plug the 0 in, right? Yeah, I can factor out an h. So I'll have negative 2h minus 6 over h. What happens then? Get rid of those. Can I plug the 0 in now? Yes. What do I get? Negative 6. Okay. Okay. The actual calculus derivative part of this is not hard. It's just very tedious algebra getting you to the end. Now let's talk about what this negative 6 actually means. If you were to graph this equation in your calculator and look at it when x equals 1, and you drew the tangent line, like in your mind, you drew your tangent line on there, the slope of it should be negative 6. Okay, so if you graph it that's a terrible version of the graph, but it's some sort of upside down parabola, right? If I go over to x equals 1, draw on that tangent line, slope is -6. It's actually a little more steep than that, but you get the idea. That's what we're finding. Okay, yes.
So on the other side,
Yeah.
when you go through step, you get the minus -1 at the end.
Okay, so it says f of 1, right?
Yeah.
So minus f of 1. F of 1 means plug a 1 in here, so that's 3 minus 2 minus 2. Which is negative. Okay, I just plugged it all in at once. What else, guys? You do. Yeah, guys, if you leave out this limit as h approaches 0 throughout, not going to be good for your grade, okay? On the AP exam in calculus, whether it's AB or BC, the notation is so important. You have to show the limit every step along the way, okay? But don't show it at the end once you've evaluated the limit. Don't tell me it's the limit of -6. No, it is not, okay? It just is -6. All right, you guys try number 2 for me. So you're doing the same thing. You're finding the slope of the tangent line. I give you f of x, and I give you an x value. How we doing, guys? Talk to each other. Guys, what'd you get?
0.
I heard 0, I heard -1. Anything else? It's -1, guys. Oh. All right, let's go through it. You what? All right, so I start limit as h approaches 0. This time I'm doing f of 2 plus h, right? Minus f of 2 all over h. It is minus. Think about slope. Y minus y, right? Don't memorize it, understand it, okay? All right, so f of 2 plus h. So if I plug 2 plus h in right here, do you guys see how I'm going to get 1 over 1 plus h? Are you okay with that? All right. So 1 over 1 plus h, and then minus f of 2 is just minus 1, right? All over h.
Wait, it's not h minus 1. On the bottom.
No. It's always just over h.
That's fine.
That will definitely throw things off for you. That's why you got 0. Okay, so limit as h approaches 0. Because if that was the case, Solomon, you could just plug the 0 in right away and be done, so. All right, I need to combine the 1 plus h, 1 over 1 plus h minus 1. So I need a common denominator, right? So I'm going to have 1 minus 1 plus h over 1 plus h over h. Lovely 3-leveled fraction. So 1 minus 1 plus h, like what does that all end up simplifying to? What? Yep, just a negative h over 1 plus h. And then what does divided by h actually mean?
Multiply.
Yeah, multiply by 1 over h. Okay, what do you see that's going to happen? They cancel, yep. And can I plug in that? Can I plug 0 in now?
Yeah.
So right here, when you're doing this common denominator, it's 1 minus all of that. It's the easy place to miss a sign. All right, so when I plug in, I have -1 over 1, right? So -1 is there. Questions? See it? Okay. Questions? It's just tedious algebra, isn't it? I mean, it's not super fun. We'll get through it. All right, third one. So now I'm asking you to find the derivative specifically, and then use it to find the slopes of the tangent lines at these given points. So you're not going to do the derivative 3 different times with 3 different x values. You're going to find the general derivative, and then you can plug in the x values to that. Okay? So, what? No. So think about my graph is this, right? So the slope of the tangent line at 1 is going to be different than at 4 and different than at 9, right? Is that slope different from that slope, different from that
I
slope?
understand that.
Yeah, no. It's good to ask that because I want to make sure you see what we're actually finding here. Okay, so I am writing out the rule again just because I want it stuck in your head. Limit as h approaches 0 of f of x plus h minus f of x all over h. So limit as h approaches 0. What is f of x plus h in this case? Plus h. Okay. Square root of x plus h minus square root of x all over h. Everybody understand where that came from?
Why don't we plug in the bottom part?
What do you mean?
Why don't we plug in the bottom part?
So you gotta go back to, like, h is just by itself on the denominator. So that's the whole point of finding slope. This is y minus y and x minus x. Remember, that just gave us that h, and we want h to get really, really small. Okay. All right. Just really want there to be an x. Okay, so I'm trying to evaluate a limit. I can't yet. So what do I do? Conjugate. Yes. So square root of x plus h plus square root of x. So limit as h approaches 0. My numerator is x plus h minus x, right? You guys see that? So are we okay with just calling that h? Can I jump to that? Yeah? You with me, everybody? Okay. If you multiply that out and simplify it, you are left with h. Now, guys, don't multiply out the denominator. Remember, leave it. H times square root of x plus h plus square root of x. I don't know. What do we do first? Yeah, that's the whole point, is so that you can eliminate your h. Every time that h has to go away so that you can actually evaluate your limit. So that is gone. So I now have the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. So what does it simplify to if I evaluate the limit? Not root h, no. Okay, h is 0, guys. There is no h in your answer. So 1 over 2 root x? Yes, okay. All right, guys, that is f prime of x, okay? That's the derivative of f of x, yes. Okay. Now, I've asked you to find, like, that's the general rule for the slope of the tangent line anywhere on this curve. At specific x values, if you plug that in, you can find the slope. So when x is 1, what is the slope? So f prime of 1 is 1/2. What about f prime of 4? One over 4. What about f prime of 9? 1 over 6. Okay. Does that make sense what you're doing? Notation, yeah, you should tell me that because that's talking to me about the slope. So did the y values matter at all in A, B, and C? No. It's just the coordinate of the point on the graph, and then the slope is different from that. All right, we'll pause there for lunch, guys. All right, guys, go ahead and turn the page. Look at the directions for 4. What am I asking of you now? An equation. Am I just asking for the slope anymore? No. So do you guys remember point slope form? Yeah. Y minus y1 equals n x minus x1. Well, I've got a point, right? You should know that. Promises. I have a point. I need the slope. How do I find the slope of the tangent line? The thing we've been doing. Yes, yeah. So we're going to go through, you're finding the derivative. We're doing that with the limit definition. Let's do it again. So limit as h approaches 0. And we can go back to doing f of 1 plus h. right? Because I actually have an x value that I'm plugging in. Minus f of 1 over h. H approaches 0. What is f of 1 plus h going to equal? 1 plus h quantity squared. And what is that?
1 plus h plus h squared.
Yeah, in whichever way you want to write it is fine. And then minus f of 1. What's f of 1 going to be? 1 over h. Limit as h approaches 0. What are you left with in your numerator? Okay, and can I factor that? Yeah, let's do that all in one step. So I've got h times h plus 2 all over h. What happens? Yes. Then can I plug in and evaluate my limit? Ah, what do I get? 2. So I have a point and a slope, right? So what's my equation? And stop there. You do not need to put it in slope-intercept. You don't need to do anything else. Just point slope. That is the equation of the tangent line at that point. So what that's talking about, we have our parabola here. There's maybe the point 1, 1. So if I actually found that slope of 2 seems reasonable, right? And then that's the equation of it. Okay? Is it making sense what we're actually finding in every one of these? Okay, I don't want you to just be like, regurgitate process, not really think about what you're doing.
What would happen if the slope was slightly like 0.001 more to the left? Like, what would that? Would it still not be a tangent line anymore?
Yeah, or you could be at the point 0.9, comma 0.9 squared. You know what I mean? Like if it moved left, you could find a new tangent line. But if your slope is off, it's not a tangent line, because it would intersect it with the other. Okay. All right, try 5.
Is it always going to be that h goes to 0?
Yes. Because the whole point is bringing those 2 points from the secant line close together, and they get close together when the distance between them is 0. Do you know what I'm talking about? Okay. All right, try 5 for me. So I have given you the equation, and I've given you the point. You are writing the equation of the tangent line again. talk to each other. How are you doing? We are. Let me write this one up here and see how you guys did. All right, y minus 1 equals, what'd you get for slope? Yes, negative 1/3 times x minus 3. How'd we do? Not good? Good. Good. Good, good. You guys get it, or are you still working? Yeah, absolutely. All right. There is no red. Hold on, let me go through 5 first. All right, so limit as h approaches 0, f of 3 plus h minus f of 3 all over h, right? Okay. F of 3 plus h is 3 over 3 plus h. F of 3 is 1 all over h. Good with me there. Okay. Limit as h approaches 0. So the 1 is going to become 3 plus h over 3 plus h. So I'm going to have 3 minus, in parentheses, 3 plus h, all over 3 plus h, all over h. Okay, that's just common denominator. Then I simplify. 3 minus 3 is going to be 0. Then I'll have negative h over 3 plus h divided by h, remember it's times 1 over h. Cancel out my h's, plug in 0, I get negative 1/3. You see it?
H is 0.
Okay, then the equation writing, you've got your point and your slope. So it's just y minus 1 equals negative 1/3 x minus 3. Okay? Question? You see it? Better? Okay. Good. All right, let's look at 6. This time I just straight ask you what is the derivative. Okay, I'm not asking you for the slope at a point, just want to know the derivative. I'm going to tell you the answer based on shortcuts. And you have to try to do it with the definition and see if you get there. Is that a not good sigh? Let's see what happens. Okay.
I know the full.
I'm saying find the derivative. I've given you the answer. I want you to do the definition of the derivative to see if you get to that. So limit minus
Minus. Yes. Listen, I didn't press it.
Okay, so if you it's just love stuff.
Simplify.
I will teach you the shortcut on your side, okay? But then you're just gonna wanna do it and never have to practice. It's super easy. Once you see it, you'll be like,
There's a lot of writing in this.
no. No. So you're just finding the
Okay,
derivative.
so you got super low.
All of these other ones, we found the derivative as
Why do the H's
number on here. This I would actually
Oh, is it H equal to F prime one?
H is 0.
find that.
So you get rid of it?
Yeah.
So it's just equal to 2x plus F.
I mean, I got 2x plus 10 in my answer.
Somewhere in your answer?
I got 2x plus 10 plus 2x squared.
Oh, I'm almost there, but I have an extra H.
Oh, 0.
Cross and it makes it better.
So, I like.
Yeah.
Okay. Cancel out H, great.
Oh.
Okay. So,
We're doing notes? You're not teacher question?
so now we're doing like limit of
We're gonna
H. We're not done with that.
So we would be.
I'm almost there, but I have an extra H, 2x. I don't know.
H, or H.
Now we found
Minus 1, which is an x to 0.
Right.
And then multiply 1 by 10.
I guess, but I think I was like, let's say, like, no, you don't.
X to 0.
No, you don't. Nuh-uh.
Okay.
X to 1.
You did plus X.
So you did minus, but now we did just a whole lot. Yeah, I got that nonsense.
Maybe E40.
So this one is.
Flavor Flav, I think it's. How do you figure it out?
Minus 1.
Ah, I got it. Minus 1. Goodness.
Is that hard to do that? Inside the answer.
This one is top heavy, right? So if I
Yeah, so find the alpha
Oh, ah.
fully understand shortcutting seriously. Then
Oh,
You hit it on.
hey.
Is it too much to get?
Alex, did you see that? Top three and then top three doubles. The whole top three. I don't play. My mother gets ready. Is it shaped sitting in
It's only.
Big fan, Alex. I really do. That's what they give it. Oh, Aryan? Yeah, but say top three. That's what you want that email says. And then top three doubles. So that's all the whole time. I think you're aren't three doubles.
You guys practice doubles?
No. So like this.
Very good.
Double is easy.
Did we get there?
Yes.
Yes?
Go down.
Anybody need me to go through it? Okay. So, limit. H approaches 0. F of x plus h minus f of x all over h, right? That should be stuck in your head at this point. So f of x plus h, that's going to be, if you think about that, that's x plus h quantity squared plus 10 times x plus h, right? So that's going to be x squared plus 2xh plus h squared plus 10x plus 10h. Then minus f of x, so minus all of that. So minus x squared minus 10x. All over h. Okay? Limit as h approaches 0. Your x squareds are gone. Your 10x's are gone. So all you're left with is h squared plus 2xh plus 10h. Right? Over h. What can you factor out of that numerator? H. So limit as h approaches 0, h times h plus 2x plus 10 over h. What happens to those x's out in front? Or h's, sorry. Not x's. Yeah, those are gone. Then you're evaluating the limit. The limit as h approaches 0. That is 0. 2x plus 10. That's it. See it? Alright guys, we gotta keep going here. This next part is super important, so I would definitely pay attention to what I say. So three common ways for a function to not be differentiable. Differentiable means you can take the derivative. So if it's not differentiable, that means you cannot take the derivative in these three cases. So if your graph has a sharp point or cusp, so do you see how this graph comes up to a point at the top? You cannot take the derivative there. The reason being, if I tried to draw the tangent line at that point, well, I could, yeah, there's too many options, because, okay, that's a tangent line, right? Isn't that also a tangent line? Isn't that a tangent line? Yeah, so there's an infinite number of tangent lines.
What if you tried? Like, what if you did all the same stuff? What would happen? What would the result be?
Well, you could try, so like if it's absolute value of x at h equals, or at x equals 0, you could go through the process. It's more, you need to understand that that's not what's differentiable. Like you could possibly get an answer and you would be wrong, because you'd find one of them. But that's not really going to help you. Okay? So, it's pointy. Do not try to find the derivative there. If it is discontinuous. So, do you see how we've got like a jump going on here? Where in the world would you draw the tangent line at that x value? No. Are you going to draw it by this hole? Are you going to draw it by that hole? What about the line, the little dot in the middle? It doesn't make sense. So, you cannot find a derivative if you have a discontinuity. any sort of hole, jump, asymptote, anything like that. The third one I think is the hardest for you guys to understand. If you have a vertical tangent line. So this graph here, it has a point of inflection at x equals 2. If I drew the tangent line, my board is a little off. We'll try again. I draw the tangent line right through 2. You guys see how it has to be a vertical tangent line? What is the slope of a vertical line? Undefined. Okay, horizontal line is 0, vertical line is undefined. That's the problem. Okay, we can't find the derivative when the slope would be undefined. Make sense?
Yes.
Okay. Those 3 pieces of info are very important. Okay, I will ask you questions based on those 3 things. Okay. All right. We are going to do a little bit on this next page. We're running out of time. All right, so number 7, where's the function f of x equals absolute value of x differentiable? So again, that means where can I take the derivative of this graph? It's not nowhere.
Anywhere but 0.
Anywhere but 0. So it's anywhere except for the point, right? So negative infinity to 0. 0 to infinity. All right, we're going to jump down to the bottom just because I want to make sure we have time for 10. So look at this super nice function. Okay, I've given you this graph. Where on this interval, -1 to 7, does the limit of the function fail to exist? So guys, we're talking about a lot of different things so far in this unit. We're talking about being able to take the derivative, we're talking about is it continuous, and we're talking about finding the limit. They're different questions. So where does the limit fail to exist if you look from -1 to 7? 5 I agree with. Look at 1. If I came from the left and the right, would they run into each other?
Yeah.
They would. Okay, so the only place the limit fails to exist is at x equals 5. All right, so where on this interval does the function fail to be continuous? Where? 5 and?
3.
Yes. And 5. Okay, where on the interval does the function fail to be differentiable? Yes. X equals 1, 3, and 5. Everybody okay with that? Discontinuity is no good. Pointy part of the graph, no good. All right, and then the final part. Where on the interval is f prime of x equal to 0?
5. Oh, f prime.
Okay, f prime, that's saying when is the derivative equal to 0? What does the derivative actually tell us?
Slope.
Slope. Okay, slope of the tangent line is 0. What kind of line has a slope of 0? Okay, where on this graph that it's differentiable do you think I have a horizontal tangent line?
On 0, the 2.
Yeah, how about right through there? Yeah? Now, when we talk about a tangent line, some of you guys are going to go, whoa, that is going to intersect your graph more than once. Yes. Okay, our graphs are not always going to be, perfect graphs where it would only touch it once. What we're thinking about is in a specific window, like, so in that little part, that is the tangent line, right? Okay. Questions on A through D down at the bottom. Okay, we're going to skip 8 and 9. Your homework is kind of a weird assortment again. As you look at your homework, the directions at the top say, for the first 4 there, it says use the definition of the derivative. The next section, it says you don't need to use the definition. That would be incorrect. You guys, that's all you know so far. You are practicing all of these with the definition of the derivative. Yeah, the limit, yep. Basically that you can't use the power product proportion. Okay. 376 through 378, those are just gonna make you think a little bit. But otherwise, it's pretty straightforward, okay? Quiz next time. We're also doing 10-4 next time, okay? Busy week.